This video is the third video in a series of 4 videos through which we learn how to use the table for the standard normal random variable. Here specifically we will learn how to deal with the probability of z being bigger than or less than a negative number or negative k. Okay, so everything here comes from the fact that the PDF of the standard normal random variable z is symmetric with respect to y-axis. In other words, what you see in the graph, if you so what we see here is that if this is the y-axis, it is symmetric. So everything happening on the positive side, it's mirror image of the negative side. That's what it means. And how this is going to help, so how to find probability of z bigger than minus k and probability of z less than minus k. So here let's just do one with details. So probability of z bigger than minus k means what? Means that we are trying to find the area of a region here. So if this is minus k, so let me do minus k. So z being bigger than minus k, it means that we are trying to find this whole thing. And this is the same thing. This is a symmetric. Remember, put the mirror there, find the mirror image, and what you will notice is that this guy is the same thing as this guy, but this time going from positive k less than that. So these two regions are the same thing, but the difference here is that this guy is probability of z less than a positive number. So this we can find it from the table. How about if it is probability of z less than minus k? Well, again, we have this nice bell-shaped graph. We are trying to find this is minus k, z less than minus k, it means it is here. And then here we have, well, by symmetry, you have that is the same thing as this thing, this region, but this time for positive k. So change the sign. And that is the same thing as probability of z bigger than k. But we know how to handle z bigger than a positive one. That is 1 minus probability of z less than k. So let me then write these two formulas here. So if you're looking for probability of z less than minus k, this is same thing as probability of z less than k. So always you can switch and drop the sign. switch the direction of z bigger than or less than and drop the sign. So then the other one is probability of z less than minus k is the same thing as probability of z bigger than positive k. And while this last piece is exactly second video, which is 1 minus probability of z less than k. So these two formulas are what we will use to handle negative z's. Okay, so let's do some examples. Then here, example, find the given probabilities. First one is we are trying to find probability of z less than negative 0.23. The second one is find probability of z less than equal negative 156. And the fourth one is probability of z bigger than negative 2.45. And the last one is, oh, I don't have 3. Okay, this is 3, this is 4. Probability of z bigger than equal to negative 3.19. Okay, we need the table. Let me import that table here. Yes, please. Okay. Let's just a bit up. Okay, this is nice now. Okay, so let's start with the first one. Z less than or bigger than negative 1. You have to handle negative sign by the symmetry. Probability of z less than a negative number is the same thing as probability of z bigger than the positive part of that thing. But this is z bigger than a positive number. We know how to change z bigger than a positive number by 1 minus probability of z less than 0.23. And now this is something we can find from the table. This is first part, this is the second part. So first part is 0.2, this is 0.2. The second part is 0.03. So go down, go this way. That's the number we are looking for, and this is 1 minus 0.5910. Well, just do that computation, and that gives me 0.904, that's 0.4090. Okay, how about this one? Probability of z less than equal negative 1.56. There are 2 points. First, since z is a continuous random variable, doesn't matter if we have less than or less than equal. The second point is that the negative sign, you have to handle it using the symmetry. So z less than equal to a negative number is probability of that is the same thing as probability of z bigger than the positive part of that. And now this is z bigger than a positive. We know how to handle that by 1 minus z less than 1.56. If you don't remember this part, this is second video of this series. And while here now we have everything we want. 1 minus, I have to find 1.5, this is here, and 0.06. We go there, we come down this way, and that's the number. 0.9406. And that gives us 4, 9, then 5, 0. That's the number. Yes. Okay. How about the third one, z bigger than negative number? Always deal with the negative number first. So z is, I can use the symmetry. Z bigger than negative number is the same thing as z less than the positive part of that, and this is something we can find from the table. 2.4 and 0.05. So let's just do that. 2.4 is here and 0.05, 0.05 just goes there. This comes down here, and that's what we have. So this is 0.9929. And again, regarding the equality, this since z is positive, continuous random variable, it doesn't matter if you have equality or not. Here z bigger than a negative number, you have to use the symmetry, basically z less than the positive of that thing, and this is something we can find from the table. 3.1 and 0.9, so this will go up to this piece here, and that number is 0.9993. Okay, let's do one question also for the other way around, finding k. So example, find the value of k for which we have this thing, probability of z bigger than k is equal to 0.7420. Okay, one thing that you may start doing here is that, okay, this is z bigger than something, yes. Z bigger than something, I can do 1 minus probability of z less than k, and that means that the probability of z less than k is equal to 1 minus 0.7420, which gives me what? 0.25 and then 7 or 8, 0. Okay, and while you may go with this argument, but then when you get here, this is something that you're supposed to find from the table, but look at the smallest value for the probabilities for this table. This is 0.5. This number is less than that. What does it have to say? Well, the first thing it has to say is that this wasn't the right idea, because we weren't careful if k is a positive or negative. So we have to then consider k to be a negative number. So probability of z less than its negative is going to be this number. This is the symmetry we are using. Now this is z less than a number is equal to something that I can find from the table. What is that? 7420. 74 should be somewhere up there. 74 20 22. It seems that I have used the other table. Let's just use the closest value here, 7422. So this was, let me just do it for 22. And that means that negative k, whatever the z is less than that, is equal to, look here, look there, So it's 0.65. And then you multiply this negative to the other side, and then k is going to be negative 0.65. So it may get a little bit trickier here, but if you do the other thing, you will notice that that's not going to work, and then you have to change the technique and do this one. Again, to deal with negative number appeared in the inequality for z, you use the symmetry. This is the argument you use, and these two are the formulas you need to know. And then, well, find the probability of z bigger than a negative number or less than a negative